For those of us just joining us, the recording failed. Just read through the page above is basically what we were just doing. Um, so we have events that are independent of each other. Now, this gives us this relationship. Probability of A given B is equal to the probability of A if A and B are independent. Let's think about what that's saying for a second to see if that makes sense. Is flipping a tails, given that you have a tall mother, just equal to the probability of flipping tails? Yeah. So if you're doing the probability of A given B, if A and B are independent of each other, doesn't matter what B is. You just get the probability of A back. So so the example I just used was flipping a coin. If your mother is over 173 centimeters tall, is that going to change the likelihood of you getting a tails? No. So those flipping a coin, mother's height, independent. So we say that if they are independent of each other, A given B is just equal to the probability of A. Because flipping a coin, doesn't matter if your mother's tall, your mother's short, it's still going to be 50-50 chance. Does that make sense, guys? Yeah. This is a relationship that we'll come back to a little bit today. So if we looked at like yesterday, remember we talked about hair color and gender as a bit more dependent, and purely for the reason societally, girls are more likely to dye their hair a different color. So there's probably slightly more blonde, for instance, females than males, I would assume. So if you were to do this, the probability of blonde hair given female, that would be slightly different than the probability of blonde hair. Yeah. So because one affects the other, we say they're dependent on each other, or one's dependent on the other. Okay. So this makes sense. If event B has no bearing on A, the probability if B is a given should not affect the answer. To go back to the previous example, the chance of you flipping heads on a coin is the same regardless of the chance of your mother being under 170 centimeters tall. From this statement, we can make the following rule for testing independence. This rule here, have we seen it before? Yeah, it's just what we did yesterday. So, if A and B are independent, we can say that probability of A given B is equal to probability of A. Sub that into our equation. So all we're doing there, guys, is we're saying that probability of A given B is the same thing as the probability of A if they're independent. This is where students tend to get stuck. They forget that if. This is only true if they're independent. If they're not independent, this falls apart. It won't work. Goodbye. So I'm just going to replace that probability of A given B with the probability of A because they are the same thing if they're independent. Rearranging that, let's just get probability of B from out from the bottom. We get the probability of A and B is the probability of A times probability of B, which is the thing I talked about yesterday. Now, I said yesterday, guys, that I'd made a mistake when I started doing that because I was doing it for events that weren't independent. We're doing dependent events, which is why that wasn't the right way to do it. It's only if they're independent will that method work. And yeah, I had a bit of a brain fart yesterday when I started doing that. So, we can say that events A and B are independent because remember, we started rearranging our equation under the assumption that A and B are independent, and that's given us this relationship. A and B is equal to A times B if they're independent only. Does that make sense, guys? Yep, and that gives us three rules that we can refer to, or three statements, I guess. Probability of A given B equals probability of A. If that is true, what can you say about A and B? If you find A given B and then you find A separately, and those two are equal, what can you say about A and B? Yeah, that's it. So that means A, comma B are independent. Same thing for the next one. B given A equals B. The exact same thing. We've just put B in the spot of A. Means the exact same thing. And if we then find that the probability of A and B is equal to the probability of A times the probability of B, what can we say about that? They are independent. If any of those three things are true, we can decide, yep, these two events are independent of one another. So this is just the way we test mathematically, or we prove mathematically that two events are independent. If I can find the probability of A given B, and I can find the probability of A, or I'm given them, and I can show that they're the same, mathematically, that means the two events have to be independent. There's no other way for those two things to be true at the same time, unless they're both independent. Okay? Questions, comments, concerns before we have a go at some problems? Elizabeth is concerned about my tapping, but she's gonna have to deal with that. Okay, let's have a look here, guys. We've got event A, B, and C, and it wants to know, are A and B independent? What is a test of independence that we could do here? The differences, how do you mean? We're going to look at what they have in common, yeah. If we look back to our rules, we have two of them about A given B, and we have one of them about A and B. Do we have enough information to do the A given B stuff here? Nah, not really. I mean, we could figure it out for ourselves. I don't want to do that. It seems like a bit of work. Do we have enough information to say what the probability of A and B is? Yeah, we can just look at the sets, see what the probability of both of them is. And there. So let's just start, guys. What is the sample space of this experiment? How big is it? 1 to 8. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 numbers. How many numbers are common between A and B? 2. So that's 1 and 3. So let's just make our little statement here. We know that A and B is just 1 and 3. So therefore, what is the probability of A and B? Yeah, we have 2 options out of 8 possibilities. 2 out of 8. Okay. Sorry? Yep.
Do you simplify that to whatever?
Yeah. You don't have to. It's good practice to get into, though. Is always reducing your fractions as far as you can. So we have the probability of A and B now, which is this bit here. What do we need to do now to check if they're independent?
Find them.
Yeah, find the probability of A, find the probability of B, multiply them together. So I'm just going to make a statement here. If probability of A times probability of B equals 1/4, what will be the end of that sentence? What is true if those two things multiply to equal to 1/4? I heard like 3 people like sort of mumbling and I couldn't make out any of it. What did you say, Roland? Don't worry. Anyone want to have a guess? Yeah. If that is equal to 1/4, A and B are independent. Because one of our independence tests is if the probability of A and B is equal to the probability of A times B. If the left-hand side is equal to the right-hand side, they are independent. Yeah, we're just saying if. So now we're going to find it out, and then at the end we'll make a statement. Yes, it is. No, it's not. Okay. So let's do it. What's the probability of A?
Okay.
1/8. Yeah, we got four things in A here.
Yeah.
Yeah. So probability of A. No, I'm just gonna do this as one line times probability of B equals 4/8, which is a half. And what's the probability of B? Same, a half. What's a half times a half? 1/4. Multiply tops, multiply bottoms, 1/4. So, what can we say? Sorry? Adding them is a whole, timesing them is a quarter. A half of a half is a quarter. So what would we say, guys? Yeah. A and B are independent. Okay, now we've got to test A and C. Now, knowing the way I like to do questions, I normally do one where the answer is yes, one the answer is no. I'm going to expect that they're not going to be independent. I don't know. I did write this a long time ago, so let's find out. Are A and C independent? So what are we going to do this time? How are we going to solve this? So what is in A and C?
4.
Just 4. So A and C is just 4, which means the probability of A and C is 1/8. That's right. So we will do the same thing now. Probability of A times probability of C equals, what's the probability of A? Well, it's a half again. What's the probability of C? Right, that's right. Wait, is that right? Yeah, there's 3. 4, 6, 8. So 1/2 times 3/8, well, that would be 3 on top over 16. Now, looking at that, is 1/8 the same as 3/16? No. However, in this case, we really don't need to check. But sometimes fractions, because they can be reduced, look different but are actually the same. It's like if you got, I don't know, 6/8 and 3/4, they look like they're different, but they're actually the same fraction. So it's always worth checking if you can reduce any of your fractions down. I'm looking at this 1 and 8. Can you reduce any further than 1/8? 3/16? No, so we're good to go. So 1/8 does not equal 3/16. Therefore, A and C are not independent.
You said that.
Yeah.
I still don't get how you tell them and they don't get.
So mathematically, Ryland, what we're doing is how we tell. In terms of like everyday life, if you were doing this experiment for real, you first use logic. Like, if we go back to the height of your mother example, of course that's not dependent. Of course that's independent. I mean, but if you do something like, what's the chance that someone does maths and science? You'd think that, well, you'd expect those two things to be dependent, because if you're doing the higher level subjects in maths, you'd expect them to be doing the higher level subjects in science, kind of thing. Aside from that, you just come back to those 3 tests. If you can show either of those 3 things are true for your data set, it means the 2 events are independent. So everything will come back to that. Okay, let's do B and C. So they have nothing in common. So There's nothing to test them with. So we've got B and C. B is 1357. C is 468. They are. Sorry. The probability of getting. So there's no. So the. Yeah. B and C. I don't know if you've seen that symbol before. That means the empty set. There's nothing in there. So the probability of B and C is equal to 0. Probability of B was 1/4, 1/2. 1/2. Probability of C was 3/8, which gives us 3/16. And I'm sure I don't need to tell you that 0 is not equal to 3/16. Therefore, not independent. The reason I'm not saying dependent, Lachlan, is I think there might be an extra step of proof to show that two things are dependent. So, because dependent doesn't just mean not independent. So I'm just all you'll ever be asked to say is, are they independent? Are they not independent? Okay. Any questions there, guys? We've only used the one test there. I'm actually going to go back to. We'll do a different question on that. We'll try and do we'll do one of the first two methods for this next question, just so you get an experience doing both ways. Any other questions before we move on? Right side of the classroom, you've been very quiet today. Your perspective, sure. But from my perspective, in other words, the correct one, you're on the right. Okay. Group of 100 students were asked if they prefer playing sport or listening to music in their free time. Results are shown below. Is a preference for a particular leisure activity independent of gender?
Sorry, part 5 plus 23. Well, you're not a math teacher.
It's pretty funny. Essential maths. I'd hate essential maths. That'd be the worst. Okay. I'm just gonna scribble out the whole thing. 25. Okay. Group of 100 students are asked if they prefer playing sport or listen to music. Obviously, there's some people that are both. There are some people that are not. And we want to see if it's dependent on the gender. So, I'm going to use the test. Use test. The probability of A given B has to be equal to the probability of what? If they're independent?
Probability of A and B. A.
Just A. I'm going to pick on Amber. What do you want event A to be? Sport or music? Sport. So, let's use the probability of prefer sport given, do you want to say male or female? Male, given that they are male, should equal the probability of prefer sport. If that statement there is true, what can I say? Yeah, the preference is independent. If they're not true, what can I say? Not independent. Now, I'm going to start on the right-hand side here, because what's the probability that someone prefers sport? Out of 100. which I'm sure you all know is 3/4. What's the probability that someone prefers sport given that they're male? 45 out of 75. No. That is the proportion of people that prefer sport. Nope.
60.
Sorry?
60. What are you asking?
What is the probability that someone prefers sport given that they're male? So if we're given that they're male, that's something we already know has happened. How many males are there? 60, so it'll be out of 60. And of those males, how many prefer sport? 45, so it'll be 45 out of 60. Does that make sense, guys? Why it's 45 out of 60? Can anyone reduce 45 out of 60 to a fraction for me? What can we say? Independent. Therefore, prefer sport is independent. Independent of gender. Now, we've shown that that is true for males and preferring sport. Let's test again, but maybe do females and music. This time we just check that it works out both ways. Because we could have theoretically fluked that they just happened to have the same likelihood. It is technically possible. So let's just do a check to make sure. So let's check using probability of music given that someone is female. And what would that have to be equal to? No, like what statement would that be equal to?
Just music.
Probability of someone preferring music. If those two things are equal to one another, we can say that it is independent. Okay, what is the probability of someone liking music?
15. 25.
25 out of 100. Sure is. And what is the probability that someone likes music given they are female? 10 out of 40. Because the probability that someone is a female is 40. Of those 40 people, 10 of them like music. So the probability, 10 out of 40, which is 1 over 4 equals 1 over 4.
So would that be, you think it's independent of gender?
Yep. Therefore, independent. We only really needed to do one test. I just wanted to go through it again. Hoping that's making sense, guys.
So if you get to a question, which one would you use first?
Something like that. If we look at this, if we were to use that third rule, probability of A and B equals probability of A times probability of B, like, it just depends how you define it. So A would be male, B would be like sport or something. So the probability of being male and sport would be 45 out of 100. The probability of then male is 60 out of 100. Probability of sport is 75 out of 100. So you just have to like multiply those things together. Both ways would give you the right answer. Basically the way I did it there though is generally what you would do if you got given information about A given B. So like in a worded question, I'd almost always use 1 and 2. If you get given it, like in the next one, it's a worded one, we're going to be using those two. This one down the bottom, you only do if it's easy to figure out A and B. If you're given A given B, if you're given P A dash B, so like a line B, 100% do 1 or 2.
So it doesn't matter either one.
Yeah, the reason why, Ryland, is because this one, can you see that there's no calculation to do? All you got to do is look at them and see if they're equal. But C, you have to do a calculation. You got to do A times B and just check that they're equal. And sometimes you might need to then, using the information you've been given, calculate A and B. But yeah, I would use 1 and 2 by preference because they're easier. Use 3 if you have to. Anyway, let's have a look at the next question. Okay. The probability that a married woman watches a particular show is 0.4. Probability that her husband watches the show is 0.5. The television watching habits are clearly not independent. The probability that the woman watches her show, given that the husband watches it, is 0.7. Can anyone tell me what's going to be without even looking at the questions, what's the issue with this question? What's going to be the difficult part? I guess the decimals. We'll just use our calculators, but they are for me. What else aside from the decimals? What is annoying about this question? You get given 3 different values. Yeah. What's annoying to me is it's not clear initially what the events are. So there should be 2 events. What would the 2 events be in this one? Yeah, so you have wife watches the show, husband watches the show are our 2 events, A and B. So I'm going to say A equals wife watches. I'm going to say event B is the husband watches. So I'm just going to use W and H for my 2 letters. What are some concrete facts we can state using our probability notation from that question there? Unpacking that question, Lachlan already pointed out there's 3 bits of information given to us. Can anyone give me one of those numbers and relate it to the probability statement that it matches? So how would you write that out?
W line H.
H, yep, for sure. Equals 0.7. What else do we know?
We can work it out.
Yep. So, excuse me while I crunch some ice. Probability of W and H is a question mark, but we can figure it out. What else do we know? Yep. So let's make a factual statement around that we can write down. Yep, 0.4. So probability of W, PW, equals 0.4. What else? So one more bit of information we got, don't we? Yep. Yep. Okay. Now, do we know about the nature of the dependence independence for this? It's not independent. Yeah. So where are we going to be using those 3 rules? No, we've already been told they're not independent. So we're not going to be using those rules. Let's look at what it's actually asking us to find. Because, yeah, we haven't even looked at the questions yet. Find the probability that both the husband and wife watch the show. So we're basically trying to find this one for A. That is the probability that the wife watches the show given that the husband watches it. Lachlan. You may. Any thoughts? What tools do we have in our toolkit to solve problems around probability? That was a bad throw. I apologize. Yeah, sure is. Yep, so what's my normal formula?
A. No. Probably A.
Alyssa? I'm going to write it normally, but yeah, you are right. I'm going to write it not rearranged. Now, we're obviously not using A and B, so let's put in the letters that we're using. We're using, instead of A, W. Whoops. Now, can anyone tell me what is the probability that the wife watches given the husband has watched it? Did you say 6 or 7? 0.7 equals. Do we know the probability of wife and husband?
I mean, what?
Yeah. It'll matter for question 2 because we're going to rearrange it. But yeah, we don't know this one yet. Probability that the wife and the husband both watch. And then the probability of the husband watching was 0.4. So to rearrange it, we would 0.5. Oh, sorry, it is 2. So 0.5. So just multiply both sides by 0.5. Now, what Alyssa said before, if she just used the second version of the formula that I showed you the other day that was already rearranged, you're welcome to do that. The reason I like to start at this formula is just because that second formula isn't on your formula sheet, so it's always worth remembering just how to rearrange, how to get there. Because my unknown is the probability of W and H. So I just want to get my unknown by itself. Once that's there, I can just read off the answer. So by timesing 0.5 on this side, it cancels out the divide 0.5. Times 0.5 on this side, it will give me the probability of the wife and the husband watching it is equal to 0.35. So there's a 35% chance of both of them watching. Questions? Comments? Concerns? Quibbles? Huh?
What's cool?
A quibble is like a minor disagreement. Yeah. So if someone has a bit of a quibble, it means they're not like mad, but they like have something to say. I don't know if it's probably not the best way of describing it, actually. Quibble is like a small question, maybe. Like I just have one little quibble with that.
So we should say
I encourage you to say that. Um, let's have a look at B, guys. So this time for B, can anyone have a crack at saying what is this question asking us to find mathematically? H given W. What was that, Roland? You didn't have a quibble. Oh, right. Okay. The probability of husband given the wife is just going to be the probability of the husband and the wife over what? Probability of the wife. Do I know the probability of husband given wife? No. That's my question mark. Yes. Yes, it is. So I do know what husband and wife is. It's 0.35. And then do I know the probability of the wife? 0.4.
wouldn't be husband be over? No, it's the last right.
It's the last one that you divide by. So that'll be 0.35 over divided by 0.4.
The probability of husband is over.
Yeah, because it means the same thing. Doesn't matter. It's in those ones. The one where the order matters is the given. I'm just thinking, should we try and solve this one without calculators? Yeah, it's not that kind of day, is it? Someone want to tell me what they 0.875? How'd you work that out without a calculator? I would go back to fractions. Don't write this down, guys, but I would say that, well, that's really 0.35 divided by 4/10. So instead of 0.44 tenths, which is 0.35 times 10 over 4, and then just reduce your fraction down. So not something like that, no. Not in tech free. Unless I do make you do that. Also, you also could have done 35 divided by 4, which would be 4, 35, 3 into 35 would be 32, which is 8. Like, just do the division by hand. Yes, it would have been a while. It's a skill that you will need to like it comes in handy. Like, there will be times in your tech free where you need to do division in your head like that. Okay, we're not going to do Pascal's triangle today. We'll leave that for Monday. So I'll pause that there. Can I borrow someone's textbook? I'll just look where the questions for this one are in your thing. You know what? I just go I'll quick check. Almost done. It's
There is Pascal's triangle part.
I don't think so.
Is that a massive thing on the exam?
There'll be a few questions on it. No, you just use the second. You get a new one of those books.
Anything more focus. Quite that thing was your strength. Yeah. After wasn't that hard? Years. So seems down. He's 7. No, I'd be older than that. What you doing? So he also that's how she wants to be. Not really. No.
Guys, page 377, question 1 to 5.
Shut up.
I want to find out what a quibble is.
Never mind.
Alright. A quibble is a slight objection or criticism about a trivial matter. I swear my students quibble at me all the time. Slight objections over trivial stuff. Yeah. That wasn't really a quibble, that was me getting annoyed at people talking about the Holocaust in class. Amazing. Wasn't really the issue. It wasn't like, you're not Jewish enough to have this conversation. It was, let's do our minutes. You just send it to next week. Can I grab his textbook?
So you're teachers if you made the violent textbooks good students?
No. Why would I? It's your education.
But I like
Facilitator. Like, should I pay this?
like more than the list.
America. I don't know. I don't know the actual number. It would have been between like 20 years, 40 years, maybe. I don't know. Not in the grand scheme. Well, I paid it all. Yeah, I paid it off 2 or 3 years ago, maybe. Um, unless you did like multiple degrees.
That would be